Evaluate the expression. 6 squared is 36. 7 squared, 7 times 7 is 49. And if we add those together, 9 plus 6 is 15. 3 plus 4 is 7. Plus 1 more is 8. So this will say 85. And this is another digital lesson today. It says, consider whether the statement is true or false. If I am 13 years old, then I am a teenager. That is true. Now if we click switch it, it's going to change it to the converse. So if I am a teenager, then I am 13 years old. Well, if you're a teenager, there's a variety of ages that you can be, from 13 through 19. So that is false. And this is because you could be 13, 14, 15, 16, 17, 18, or 19 and still be considered a teenager. The original statement said, if I am 13 years old, then I am a teenager, which is true. But the converse says, if I am a teenager, then I am 13 years old, which could be false. How do you think statements and their converses relate to each other? If one is true, does that mean the other is true? Not necessarily. One can be true, while the other may be false. In some cases, they may both be true, but in others, we might have one true and one false. This one says, if Mr. Adams is Sarah's teacher, then Sarah is Mr. Adams' student. If he is her teacher, then she is his student. That is true. What is the converse of this statement? So we need to swap it around. The if stays in the position, but instead of if Mr. Adams is Sarah's teacher, it should say if Sarah is Mr. Adams' student, then, and we're going to swap it for the other piece here. And we're just going to do a switcheroo there. So if Sarah is Mr. Adams' student, then Mr. Adams is Sarah's teacher. So, if is the converse true or false? If Sarah is Mr. Adams' student, then Mr. Adams is Sarah's teacher. That one is true. How do you know? If she is a student of Mr. Adams, oops, I included an extra S there. Then he must be the teacher. Earlier you said that they are not necessarily going to be the same. One could be true while the other could be false. What do you think about statements and their converses now? I think it will depend on the statement. Here it was very clear that the teacher-student relationship exists even if we switch the order around, but the teenager and the age relationship doesn't always have to go hand in hand. Consider this statement of the Pythagorean theorem. This says, a triangle has side lengths A, B, and C, where C is the length of the longest side. If the triangle is a right triangle, then a squared plus b squared equals c squared. What do you think the converse of the Pythagorean theorem is? Well, we would switch around if the triangle is a right triangle with the Pythagorean theorem. So it's going to sound like this. If a squared plus b squared equals c squared, then the triangle is a right triangle. Do you think the converse of the Pythagorean theorem is true? Meaning, if that relationship exists, then it has to be a right triangle. Yes, I believe that is true. Can you find side lengths that do not make a right triangle? Well, I see here that 90-degree angle continues to show up in that corner no matter what a and b value I use. You can see that the hypotenuse, this value of c, adjusts according to the other two sides. So when the Pythagorean theorem is used to find the c value, or the length of c, the hypotenuse, then the right angle, or the 90-degree angle, always appears, always shows up. All right, let's watch this little clip here. So the Pythagorean theorem. A triangle has side lengths A, B, and C, where C is the length of the longest side, or the hypotenuse. Then the triangle is a right triangle. So we had to prove this a squared plus b squared equals c squared. For the converse, if they have these side lengths, then this relationship is going to show, or this relationship shows up, so then it must be a right triangle. So that means we need to prove that the triangle using this relationship is in fact a right angle. So it says, prove that the triangle is a right triangle. What do we know about the side lengths of this triangle? We know that when we square the length and add them together, we get the value of c squared. What are we trying to prove about this triangle? We are trying to prove that the triangle has a right angle in it. That it has a 90-degree angle. It says, what is the same about triangle 1 and 2? The length of A and B are the same in both triangles. What is different? The second triangle has a right angle and an unknown side. Let's label the length of the hypotenuse x in triangle 2. So you can see they've labeled it x. Using the Pythagorean theorem, what do we know about the two the triangle 2's side lengths? Well, we know that since it's a right triangle, a squared plus b squared equals x squared. So since it's a right triangle with that right angle in the corner, we can use Pythagorean theorem to say a squared plus b squared equals x squared. Triangle 1 and triangle 2 have the same 3 side lengths. Defend that claim. If we use substitution, we can say these things are both equal. So that must mean that c squared is equal to x squared. And if we take the square root of both sides, we would see that c is equal to x. So they have the same 3 side lengths. A, b, and c is equal to x. So those are the same size as well. Triangle 1 and triangle 2 are congruent. We have to defend that claim. All 3 side lengths are the same, and we saw that A and B were just translated. If C is equal to X, then we know that because rigid motions preserve distances, that these triangles are congruent. They are the same. We can map one onto the other. It says, finish your proof by explaining why triangle 1 must be a right triangle. Since they are congruent, the two triangles will have the same side lengths and angle measures. Since triangle 2 is a right triangle, or it has a 90-degree angle, triangle 1 must also have a right angle. Being congruent means they have the same side lengths and the same angle measures. So now we're going to check. Do these make right triangles? So we are going to use the two smallest for A and B and the longest one for C. So 3 squared plus 4 squared, does that equal, 5 squared? 3 squared, that's 9. 4 times 4 is 16, and 5 times 5 is 25. 9 plus 16 is 25. So yes, this one is a right triangle. 6 and 8 are the two smallers, and 11 is the largest, so that's going to go in the C position. 6 times 6 is 36. 8 times 8 is 64. 11 times 11 is 121. 36 plus 64 is 100. 100 does not equal 121, so this is not a right triangle. 0.5 squared and 1.2 squared, those are both smaller than 1.3, so that's going to be our hypotenuse. 5 squared is 25, but 0.5 squared would be 0.25. 12 times 12 is 144, but 1.2 times 1.2 would be 1.44. 13 times 13 is 169, but we would have the decimal there. Let's check if I did 1.44 plus 0.25. 4 plus 5 is 9. 4 plus 2 is 6. 1 plus 0 is 1. So yes, 1.69 does equal 1.69. So this one is a right triangle. Now let's sort those into their correct positions. This does not, makes a right triangle, makes a right triangle. All right, so then this slide is going to show whether our class believes these things are right triangles or not. So far, I'm the only one who has answered, so it's 1 for each of them. Make sure that your warm-up is finished and any notes that you need to take in your workbook are written down as well.